All right, today we're jumping into something really cool. We're going to deconstruct a Python script that does something I think is pretty remarkable. It teaches one single AI model how to think in three completely different ways. You've got the careful author, the super fast drafter, and a hybrid of the two, all in one package. We're going to see exactly how it pulls this off, and along the way we'll uncover some of the smartest tricks in modern AI engineering. Let's get into it.
So, right off the bat, you've got to be wondering, how is that even possible? I mean, how can one AI learn to be so methodical and careful, but also lightning fast, and then something in between? That's the big question, the core puzzle we're going to solve today as we take this script apart, piece by piece.
So here's our game plan. First, we'll define these three ways of thinking: AR, NAT, and SAT. Then, we're going to peek under the hood at the model's actual blueprint. After that, we'll fire up the training engine to see how it learns so well. And finally, we'll see it all come together in the three-generation methods and check out the awesome toolkit that makes this whole thing so powerful.
Okay, first things first. Before we can understand how this model is so flexible, we need to get to know the three different personalities it can take on when it's creating text.
First up, we have autoregressive, or AR for short. Now, this is the classic approach, the methodical one. Think about how you'd carefully write a sentence, one word at a time, right? Each word you choose depends on all the words that came before it. It's slow, it's careful, it's coherent, and it usually gives you really high-quality results.
Next, there's non-autoregressive, or NAT, and this one is the polar opposite. Instead of going word by word, NAT just, boom! It generates the entire chunk of text all at once in parallel. Imagine spitting out a whole first draft in a split second. It's incredibly fast, but, it might need a little tidying up afterwards. And that brings us to our third mode, semi-autoregressive, SAT. And yeah, you guessed it, this is the hybrid, the Goldilocks option, right in the middle. It doesn't do one word, and it doesn't do the whole thing. It generates text in chunks or blocks. It's kind of like writing a paragraph at a time. Way faster than AR, but a bit more structured than that. So really, it all boils down to this classic trade-off between speed and accuracy. You can see here that AR is the slowest, but often the most accurate. NAT is an absolute speed demon, but the quality can be a bit of a mixed bag. And SAT, well, it lands right in that sweet spot in the middle, balancing both. The really amazing thing about this script, though, is that it doesn't force you to choose. It lets the AI master all three. Okay, so now we know what the three modes are. Let's get into the how. How on earth is this model actually built to be so versatile? It's time to look at the blueprint. The whole model is built using this one repeating component called a block. Seriously, think of it like a single Lego brick. And this brick does the same simple four-step dance over and over. It normalizes the data, runs it through an attention mechanism, normalizes it again, and then passes it through a feed-forward network. That simple sequence, stacked again and again, is basically the heartbeat of a modern transformer AI. But inside that little Lego brick, there's a really clever trick. Instead of using standard, heavy-duty attention, this model uses something called low-rank MHA. The best way to think about it is like compressing a huge high-resolution photo. It finds a smarter, simpler way to represent the complex relationships between words. This makes the most expensive part of the model way faster and more memory efficient, all without losing the important stuff. It's a huge win.
And here's another piece of brilliant engineering. You ever wonder how an AI knows that dog bites man is different from man bites dog? Well, instead of rigidly numbering each word's position, this model uses a clever idea called alibi. The logic is super intuitive. The further apart two words are, the less attention they pay to each other. This creates a really flexible sense of distance that just works, no matter how long or short the sentence is.
So a great blueprint is one thing, but you need a powerful engine to actually bring it to life. So let's check out the training process and see how this script forges such a tough, resilient learner.
I love this. The developer left a comment right at the top of the training script, and it's not just a comment, it's a mission statement. You see words like back off and progressive block growth, and it tells you this isn't just a simple script. This thing is a battle-tested system designed to handle errors, optimize itself, and just survive the brutal process of AI training. So let's break down what that text speak actually does. These features are all about making the training process as smooth and painless as possible. back off is there to stop it from crashing. Progressive growth makes it faster over time, and safe checkpoints make sure you never lose your progress. Let's start with back off, Because anyone who's ever trained a model knows this pain. You're hours in, and then bam! Out of memory error, crash. It's the worst. This script anticipates that. It's wrapped in a little safety net that catches the error, automatically makes the data chunk a bit smaller, and just tries again. It literally heals itself.
Then you've got this other smart feature, progressive growth. The trainer isn't static, it adapts. You can see here, it starts out with a smaller, safer data block size. But watch what happens as training goes on. At 50,000 steps, it gets bigger. At 100,000 steps, it gets bigger again. It's intelligently ramping up over time to get faster and squeeze every last drop of performance out of the hardware.
So, we've got a flexible architecture, we've got a robust training engine, now it's time for the payoff. How does this all come together to let us generate text in 3 completely different styles?
Well, it all comes down to these 3 separate decoding functions. The rdecode function is our careful writer, using a memory cache to make sure the output is super coherent. NAT decode is our speedster, working in parallel for maximum velocity. And SAT decode is our balanced hybrid, generating in chunks for that perfect mix of speed and control.
And here is the absolute key takeaway. This is not 3 different models. It's one single core model that has 3 specialized output layers, or heads, attached to it. So just by picking which head you want to use, you can switch the model's entire personality on the fly.
And finally, let's just touch on why this script is so much more than a cool model. It's a complete, practical, honest-to-goodness toolkit for generating text. This is what makes it so useful in the real world. The script doesn't just make text, it gives you a whole control panel full of knobs and dials. You can tweak its creativity with things like top case sampling, or you can apply penalties to stop it from getting too repetitive. These are the precision controls you need to get the job done. So when you put it all together, the multi-mode design, the resilient training engine, and this whole toolkit of controls, you've got way more than just lines of code. What you have here is a masterclass in practical, robust, and incredibly flexible AI engineering.
And all of this leaves us with one final thought. We've seen how a single model can be engineered to literally think in multiple ways, adapting its strategy whenever needed. So the real question isn't just about the code anymore, it's about what comes next. As tools this smart and this flexible become more common, what new problems are you going to solve with them?